Good morning. You are welcome in AI with Rao, and let's make AI simple. So in this journey at 14th day, we are going to learn the second model for unsupervised learning, and that is PCA. We will learn its full form. Rather than learning the full form, we will understand what is this. Okay. So this is casting a perfect shadow. This you need to remember. That's one simple line. Okay. So what are the topics we are going to cover? Why too many columns is a real problem. The first thing, what is PCA, casting the shadow on a wall, and the best angle. You can see where the data spreads the most, best shadow versus good shadow, and how much shape you should keep. These are the topics we are going to cover. So let's start with the simple one-liner and same story, because that's what resonates. Okay, so the story is, you have a say 3D picture, so this one, and I just like cast, I want to I put a this, you can see right now you have image signing a 3D object and you want to put a shadow. So I have a torch and I put a torch there for this one. What will happen on the wall there, behind the wall, it will create a shadow. This is a 3D image and the shadow is going to be a 2D image. Now the real smartness is, what should be the angle of this torch? This is not a torch, but I suppose this is a torch. And what should be the angle of this torch so that the maximum information I can get on the shadow from this object? And that the maximum best angle is finding the real pain point is here. And that's what we are going to do in machine learning model. So this is what the whole story is. Now come to the real problem. And the real problem is in real life. So take my example. If you ask me, give me how many properties are there in my case, it can be 100, like 1000. Okay, let's suppose 100. I have my age, income, height, weight, steps, sleep, heart rate, so many, say 100 columns. Now the target is to reduce all this information, because so many informations are there. Okay, for one person, for me only. Okay, here for one person, here you can see for one row 100 columns are there. Now for second person 100 columns. If I want to ask you that, can you draw this on a 2D diagram and understand the pattern? Impossible, right? Because how many, so in 2D diagram you have y-axis and x-axis, so you can take 2 dimensions. Now there are 100 columns, you have to draw 100 dimension. Impossible to draw and find a pattern, right? But suppose if I ask you what is the height and weight, then you can take it, this is height and this is weight, and you can draw the pattern, say 100 people, and see, okay, what is the pattern that is coming out from your eyes. This is the motive, and that's what we are going to do. You got the point? You can read the PDF line by line, that's not an issue. Okay, so this is the agenda, to converge these 100 columns into 2 columns, 3 columns, provided we don't lose, or we are not losing the most important information. You got the point? So that is the intent. Now let's start with the diagram. As I saw this demonstrated this example, now it is in the picture. Right now this is the light and this is the object, 3D object. You can take it as a cube, and this is the wall, and what we are getting is this shadow, 2D shadow of 3D image. So one dimension get reduced. You got the example? Now I will ask you, what is the best angle of this light that we will get the image on the wall which will have most of the information of this 3D cuboid or cube. Now take an example of this data. What is the best? So you have this sheet. On this sheet, these dots are nothing but the information. If I ask you that what should be the line, which line you should choose so that you will get almost most of the information from this, most of this dot will be covered, which line you will choose, this yellow or green? First we will choose this yellow one, because this is the line where all of the informations are there, and this is called PC1. What is PC? Principal component. This is the first principal component where most of the information is there. Okay. Now you will ask, what is second? Second is PC2, principal component 2. That is the angle. You draw a 90-degree angle and draw a line, and this second direction of a straight line is PC2. And believe me, this 2 dimensions only covers 90% of the information about this data, and this is what called PCA, principal component analysis. Now you got the whole thing. Let's understand which is the good shadow and which is the bad shadow, again with the example and the diagram. See, you in the left side you can see right now, if I draw a straight line like this with this information, I will get nothing, almost no information about my data points, because how much information you can get? That nothing, just only this part. But if I am going to draw this green line in diagonally, 90%, more than 90% to the information I will get about all these data points. So this is the bad angle, this is the good angle. You got the point? This is what, and in good angle we can also get another information by drawing right angle and get the straight line, that will be the PC2, principal component 2. You got this point? And now the formula. See, formula, there is no fancy formula. So PC1 is the direction with the most variance. I will explain you what is variance. Just understand, variance is just spreadness. And PC2 is the next most. That's it. Keep only top few, drop the rest. Now comes what is variance. So variance is how spread the data is along a line. That's simple. More the spread, higher the variance. Now the second thing comes is principal component. That just a fancy name. It means a direction that casts along the shadow. Simple. You can see it now. A direction that cast the shadow alone. That's it. Rank by how much it is spread it captures. And PCA is principal component analysis. We just keep top 2 and top 2 or top 3 and then drop rest of, because there is the place where most of the information lies. Okay. Now comes this one. This diagram. From this diagram you can understand that what I am talking about. This is what the information is. So we have a data, and we have say hundreds. The data that I mentioned you in the beginning had hundreds plus columns. Okay. Now we did the PCA. This is the PCA 1 that is coming with 62% of the information, PC2 coming with 28% of the information. Rest of this PC3, PC4 and PC5 have only 6, 3 and 1% of the information. And if I ask you which two things you should prefer, you will definitely say PC1 and PC2, because these two only covers 90% of the information about the data. Then why should I compare? Why should I keep this PC3, PC4 and PC5? Drop it. This is not creating value. You got the point? This is what I have explained here in the whole text. Now real thing is, you can't skip this, is the Python programming, because this is what the training is. So we imported PCA and this PCA and N component. How many components we are going to squeeze all this 100 columns to 2 columns? So we took 2 columns. Now x small PCA.fit, x is a transform. What is 100 columns into small 2 has? That's simple. Explain variance ratio. It will tell you how much percentage of data it is going to take in PC1 and PC2. That is almost 90%. Now you have a plot between x and a normal 2D diagram, and see the group. You can see the pattern of 100,000, millions and trillions of people. What is the group? What is the general tendency? This is what we are looking for in unsupervised learning. You can see right now how important it is. It is a tool that is going to work for other model as well. So we will learn about this. Now the real problem, where does it shine and where does it sleep? First two things, it sees the unseenable. So if you have 100 columns, and if I'm going to give a data of 100 people and ask you to see the pattern, you can't. But if you do PCA and you convert that into 2 columns, and then you can see and draw the diagram and understand the pattern, that's the benefit it has. Now the speeds things up and removes the noise, because we are not considering those PCA which covers 6%, 2% and 1% of the information. We are neglecting. So it is giving the only meaningful thing. Now only catches the straight line, not the spread. This is the problem. Okay, if data is spread along a straight line, it catches very effectively. But if it is not present in a straight line or in a curve, there are other models that will sign that. We will learn that. And scale your column first. This is what we do. So you will need to, so what does it mean, scale your column first? Say some column, say if I'm mentioning my weight in terms of kg, so it will be like for people, it will be around 30 to 150 kg. But another column is there which writes the salary in rupees, so it will be too much. So difference between 85 and 3 lakhs, so much. So you have to scale both the data that will be very comparable, like 300, 200, these kind of. So make this data comparable, that will reduce your burden. Now this 20 seconds recap what we learned till now. Okay, we squeeze 100 columns into 2-3 columns and see finally the data and the pattern. We understand what is casting a shadow to find the best angle for the survival. And good shadow what is good shadow? Is to keep the most relevant data. Okay, and how much we should keep? About 90%. You can see right now. So this is what we learned so far. Thank you so much. Next we will understand what is overfitting and underfitting. This is, you should never miss, very important in machine learning. So thank you so much for being there till now.